All right, ladies and gents, today we're talking about operations with matrices. Operations meaning adding, subtracting, and multiplying. Adding and subtracting are super basic. Multiplying is a little bit more involved. I'll show you exactly how to do it. But when we're talking about matrices, okay, you can name or denote a matrix by a capital letter. So see how they have like here A. This is matrix A, just a capital letter. It represents a set of elements. So each one of these are called like entries or elements of your matrix. It's just a rectangular array of numbers, all right? It coordinates with, yes, our systems of equations, but we're going to work with ones now that are a little bigger and such, still with systems of equations, but we're not going to use the letters. We're just talking today about how to add them, subtract them, and multiply them. When you're adding and subtracting matrices, dimensions have to be the same. That means a 2 by 2 has to go with a 2 by 2. A 3 by 1 has to go with a 3 by 1. If the dimensions are not the same, you cannot add them. All right? Does everyone understand that? When you have scalar multiplication, all that means, scalar multiplication, is when you distribute. If you have something like 3a, what does that mean to do? What does 3 and a together mean? You're multiplying a by 3. So anything that's inside that matrix, you're multiplying by 3. But the dimensions have to be the same. If they're not, they cannot be combined. On WebAssign, I think it tells you to say impossible, and I'll show you how to show your work for something like that. But let's just go through some examples here. First thing you need to do is make sure the dimensions are the same. So what are the dimensions of the first matrix in A? It's a 2 by 2, all right, row by column. What is the dimension of the second one? It's a 2 by 2. So since the dimensions are the same, can we add them? Yes. So you just keep the corresponding entries with the corresponding entries. Top left with top left. What's -1 plus 1? 0. If you want to go down, that's fine. If you want to go to the right, that's fine. Doesn't matter. But what's 0 times or plus -1? -1. What's 2 plus 3? 5. And what's 1 plus 2? 3. So there's your answer. You just added them together. That's it. So if you are adding or subtracting, the dimensions have to be the what? The same, okay? So this one, what's B? The first matrix in B is a 3 by 1. What's the second matrix? A 3 by 1. So can we add them? Yep. So 1 and -1 gives me 0. -3 and 3 gives me 0. -2 and 2 gives me 0. That's a special kind of matrix. We'll talk about it later, but looks like a stoplight. But you're just adding and subtracting. So look at the next one. If I'm going to add these two together, okay, what are the dimensions of A? A 2 by 3. What's the dimension of B? A 2 by 2. Can you add these together? No, it's impossible. That's what they ask you to say on WebAssign. That's what you can say on your quiz or a test. Why is it impossible? Because the dimensions are not the same. You guys are showing me that the dimensions are not the same by writing out the dimensions of each matrix. Does that make sense? All right, scalar multiplication, like I just said, it's just the distribution property. You have a number out in front of your letter for your matrix, and what are you supposed to do with it? It says 3a. This is scalar multiplication. All this means is you got a big 3 right here. So what do you do with that 3? You distribute it where? To everything, all right? Take your time. 3 times 2 is 6. 3 times 2 is 6. 3 times 4 is 12. 3 times -3, -9. 3 times 0, 0. 3 times -1, -3. 3 times 2, 6. 3 times 1, 3. 3 times 2, 6. And there's your answer. Questions? All right, scooting along. A little more complicated, but nonetheless, nothing we can't handle. What are they asking you to do here? Multiply A by 3, and then what? Subtract B. Okay, good. Just watch what you're doing. So I'm going to go ahead and put my 3 right here, and I'm going to go ahead and multiply. So 3 times 2 is 6. 3 times 2 is 6. 3 times 4 is 12. Check me, make sure. 3 times negative 3 is negative 9. 3 times 0 is 0. 3 times negative 1, negative 3. 3 times 2 is 6. 3 times 1 is 3. 3 times 2 is 6, right? And then I have minus whatever my b is. So 2, 1, negative 1, 0, negative 4, 3, 0, 3, 2. There's two ways that you can look at this. Some of you like to subtract numbers. That's fine. But I feel like sometimes we miss signs when we have a lot of stuff going on like this. So I think it's best, and again, it's up to you. Do what you want. I like to change this to a plus sign and then distribute the negative. So what happens to everything inside the second matrix? The sign changes. So all the positive stuff becomes negative, and all the negative stuff becomes positive. If you do not want to do that, you don't have to. You can just subtract like normal. I just like to do that. So what is the result after we multiply a by 3 and then subtract? What is 6 plus negative 2? 4. What is 6 plus 0? 6. What's 12 plus 0? 12, right? Negative 9 and a negative 1 is negative 10. 0 and 4 is 4. Negative 3 and a negative 3 is negative 6. 6 and 1 is 7. 3 and negative 3 is 0. And 6 minus 2, or 6 plus a negative 2, is 4. So that would be your answer. Questions? No? All right. All right, look at the next one. Somebody asked me last period, why is the X capitalized? I'm not sure. It doesn't make it any more special. Did you see Mr.? Okay. So I'm going to say, all right, it says to solve for X. So I'm going to write my equation. 3X plus A equals B. Don't even look at your matrices right now. Let's just solve this equation. What would you do first? How'd you get X by itself? What would you do? Subtract the A. Good. So you have 3x equals b minus a, and then what? Divide by 3. So you can look at this two different ways. You can take b minus a and divide it by 3, or you could do what? Yep, you could say x equals 1/3 times b minus a. What is important to remember here, guys? If you're dividing by whatever number, that means you divide every single entry in there. Do not divide everything in B first and then everything in A first. That's not what that's saying to do. You subtract them first and then divide, or multiply by 1/3. Now, order is important here. This says B times A, so your B matrix comes first. Negative 3, 2, 4, and 1. Minus A, which is 1, 0, negative 2, 3. And then when we're done with that, we're going to multiply by the 1/3. So again, yes, ma'am.
Where is like the x? Because like in the one above, like you just said like 3a minus 3.
We're solving for x. This is x equals. So you can just leave it as subtraction if you want to, or you can go ahead and distribute your negative. So I'm going to say plus and then change all the signs behind. So you have your 1/3 out here. In my new matrix, I have negative 3 and a negative 1 gives me negative 4. 2 and 0 gives me 2. 4 plus 2 gives me 6. And 1 plus negative 3 is negative 2. Now notice, the one above, I did all the rows first. And then this one, I did all the columns first. It doesn't matter. As long as you keep the corresponding entry with the other corresponding entry. If you're adding and subtracting, you have 3 or 4 in a row that you're doing that too. Just make sure top left always goes with top left, top left, top left. So now what do I do with this 1/3? I distribute it. Guys, on your quiz, on one of the questions, it said no repeating decimals. And you guys, some of you told me x equals 1.33 repeating. That is not okay for solving an equation where you're then plugging back in to find the other. If it says no repeating decimals, don't write a repeating decimal. I told you before, stuff starts out in fractions, leave it in fraction form. There's no reason to tell me that 1/3 times negative 4 is negative 0.133 with a line over it. You guys aren't in elementary school anymore. Leave this as negative 4 over 3. 1/3 times 6 is just 2. 1/3 times 2 is 2/3. And 1/3 times negative 2 is negative 2/3. And there's your answer. Questions? Super basic. I know. All right, we're going to do 2 multiplication problems, and then you guys can start. Episode's kind of long. I know it is. It's fine. All right. Matrix multiplication is a little bit different. All right, you're gonna think it's a little weird, but it's different from our normal multiplication. If I said 3 times 2, what does that equal? 6, okay? What does 2 times 3 equal? 6, right? You can just switch the order. It's not a big deal. Doesn't work that way with matrices. If you multiply A times B, it's not the same as multiplying B times A. Doesn't work that way. And the reason why is with addition and subtraction, your dimensions have to be the same. When you are multiplying, the dimensions in the middle have to be the same. So in order for something to be able to be multiplied, you write out the dimensions. If the middle 2 numbers are the same, yes, you can perform the multiplication, and the outside numbers are the structure of your answer. Meaning, if you were multiplying a 3 by 2 by a 2 by 3, yes, since the middle numbers are the same, you can multiply them. Your answer would be a 3 by 3. So there's a little bit of a process to this. It's not incredibly difficult. You just have to kind of pay attention a little bit. So look, I want to multiply. We're going to multiply 2 ways. We're going to multiply A times B, and then we're going to multiply B times A. So if I multiply A times B, all right, well, first of all, this is how you show me your work. What are the dimensions of A? It's a 3 by 2, right? A is a 3 by 2. What is B? It's a 2 by 2, 2 by 2. So if I can multiply these together, the middle number has to be the same. Is it? Yes. Okay. So that means my answer is going to be a what? A 3 by 2. Now, every time I do an answer key, anything like that, I do this, what I'm about to show you, because I think it just keeps your mind straight. I draw out kind of a little picture of what this should look like. 3 rows and 2 columns. That's what your answer should look like. Because it doesn't look like, it not necessarily always looks like one of the matrices that you're starting off with. So the way that you do this, guys, I'm going to find this entry first. That's going to be what I'm finding first. What entry is that? What row and what column? It's first row and what? First column. So you're going to take the first row and the first column. You're going to multiply first times first. So -1 times -3 gives me what? 3. And you add it to second times second. God bless you. What's 3 times -4? -12. What's 3 and -12? -9. Perfect. Now, it's up to you what order you want to go in. I like to do all the rows first. So I just found this entry right here. Right? This one right here. Now I'm going to find this one. So think about, where is that? It's first row, correct? Agreed? What column? Second column. So the numbers that I'm going to be multiplying together is first times first. -1 times 2 is what? -2 plus second times second. What's 3 times 1? 3. So what's -2 plus 3? What's -2 plus 3? 1. Here you go. Questions? Multiplying is a little bit different, okay? So if you get yourself lost, you're like, wait, I'm so confused, I don't know what to do, okay? This is the entry I'm trying to find right now. Where is that entry, guys, in your answer? What row, what column? It's in the second row, and it's in the first column. So there's, you point yourself to what you're supposed to put together. So first times first. What's 4 times -3? -12 plus, what's -2 times -4? -2 and -4 is 8, right? So what's -12 plus 8? What is it? -12 plus 8? -4, okay. So now I'm going to find this entry right here. If you wanted to find one below it, that's fine. You would just say to yourself, okay, I'm in the third row, first column. But I'm going to find the one to the right. So I look at this and I say, okay, what I just circled in pink is what I'm trying to find. Where is that? It's in the second row in the second column. So that means I'm going to multiply together 4 times 2, which is first times first. 4 times 2 is 8, plus -2 times 1. So -2. What's 8 minus 2? Perfect. Just takes a little bit of time. Once you guys get the hang of it, you'll fly through this. All right, we found 4 of them already. Now I'm going to come here. I'm going to find this one. What row, what column is that? It's in the third row, and it's in the first column. So first times first. What is 5 times -3? -15. Plus, what's 0 times -4? 0, so this is -15. Good. And then last, guys, where? What's your last one? Third row, second column. First times first. 5 times 2 is 10. Plus 0 times 1 is 0. So here is your answer. And all of your supporting work is this basic elementary stuff that all of you can do. Now, I do not know if you'll have a calculator or not on this test. But you need to show me. So if you do make a silly little mistake, you tell me that -2 plus 3 is -1 versus +1. I don't have to take off full credit. If you make a little mistake, I can try and find some points for you. But if you don't show me your work, I can't. All right, so now if we went the other way, guys, say we wanted to multiply B times A, okay? What are the dimensions of B? 2 by 2. What's the dimension of A? 3 by 2. Can I multiply these two together? Why not? The middle numbers are not the same, so this would be impossible. So understand that if it tells you to multiply something by you, the order matters. 90 million other times we do multiplication, order doesn't matter. But when you are multiplying matrices together, order matters. Does that make sense? Look at this last one. Can we multiply these two together? Well, let's get it set up. What is the dimension of the first matrix? It's a 2 by 3. This is how you guys would show me on WebAssign and on your test. What is the dimension of the second matrix? It's a 3 by 3. So I look and I say, okay, are these numbers in the middle the same? Yes. So what is my answer going to look like? It's going to be a 2 by 3. So give yourself a quick little picture. It's going to be a 2 rows and 3 columns. So it's shaped a little differently. So now we're going to have 3 numbers that we have to multiply and add together. No big deal. I'm going to work on this piece right here. What I have circled in blue is what row, what column. I'm going to try to do it without highlighting. What row, what column? First row, first column, right? So 1 times -2 is -2. 0 times 1 is 0. And 3 times -1 is -3, correct? Did I do that right? Guys, first row, first column, 1 times -2, -2, 0 times 1, and then 3 times -1. So when I add those together, what do I get? What's -2 plus 0 plus -3? -5, okay? Got that one done. So now let's go here. Now again, if you wanted to go below it, that's fine. You would just go second row, first column. So I'm in the first row still. But now what column? Second column. So 1 times 4 is 4. 0 times 0 is 0. And 3 times 1 is 3. So what's 4 plus 0 plus 3? 7. Good. That one's done. All right, now let's go here. First row, what column? Okay, so first row, third column. What is 1 times 2? 2. 0 times 0, right? And 3 times -1? So what's 2 minus 3? -1. Good. It's hard to do it without highlighting. I know that, but you're not going to have the luxury of having notability. So see if you can try to do it without highlighting. Maybe not all these times, but as you get going a little bit. All right, now in green. What row, what column? Second row, first column. So 2 times -2 is -4. -1 and 1 is -1. And -2 and -1 is +2. So what's -4 minus 1 plus 2? -3. Perfect. All right, that was done. Run out of colors. All right, so we're going to go here. What row, what column? Second row, second column, right? So second row, second column. 2 times 4 is 8. -1 and 0 is 0. And -2 and 1? -2. So what's 8 plus 0 minus 2? 6. Okay, and then the last one. We're in the last row, second row, third column. So 2 times 2 is 4. -1 and 0 is 0. And -2 and -1 is 2. So what's 4 plus 0 plus 2? 6. So here, ladies and gents, is your answer. And your little supporting work all around it. I do think this is a very big visualization, very big help for you to figure out what goes where. Keep asking yourself, I'm looking for this entry, so it's what row, what column. And then you know what to multiply together to then add. Questions?